Welcome back everyone. In today's video we're going to deal with something new, and this is called texture arrays. And no, we're not creating a bunch of textures and then throwing them into an arrays object. That's not what texture arrays are. Texture arrays are a functionality that's built into WebGL 2.0. It's a really great alternative to using texture atlases. And I made a video a long time ago about texture atlases, which is just a grid of textures, or actually one texture divided in a grid, and you kind of just have all your little square textures in there, and you kind of have to calculate the UV coordinates based on the grid coordinate system. So it requires a bit of math, and you can screw things up, and you have like float pointing errors that can probably not give you the perfect texture position. So texture array is like a great alternative because it's all built in. You don't have to worry about any of the math. All you have to say is I want element 0, 1, 2, 3, whatever it is, and there you go. Now the only difference is when you create an array texture, this is what an array texture looks like. It's your one texture as a line as an array. This is like what you visually would say a texture array looks like. This is really what it is. This is the texture we're going to use for our texture array. I created these textures and for a specific reason. Also, stay to the end because I have a very fancy, really cool surprise for you guys at the very end. So we're just going to deal with texture arrays, and then we're going to use texture arrays in a really fun, awesome way. So if you care about it, stick around. Else, just once I'm done, just leave. All right. So texture arrays. I want to just talk a little bit about the data and how it works, so maybe you get an idea why it is the way it is, why we have to set certain things. To set a texture array, we had to define its width, its height, and how many. And there's a reason for it. So let's say this is an image. This is a 2 by 2 pixel image, and this makes sense as 2 pixels by 2 pixels. But it's as data. The image is stored this way. It's just an array of information. But we know it as this. So we know it's defined as, 2 by 2. But, in a texture array, we have 2 more textures. We added, so it's an array of textures. So in data-wise, this is what it looks like in the binary data that makes up the image. This is like a representation idea of it. It's not really how it really looks. Each pixel is like 3 or 4 floats. So, or no, integers. It really depends on the data type. It's probably the integers because it's values. Blah, blah. I don't want to go through it. I'm not going to deal with the RPG and different data. But trust me, they're most likely ints. So this pixel data. So we know that if we want to, so before when you want to calculate something, we need to know how many columns there are, or basically width. We need to know its height. So for this example, we know we have 2 pixels wide, and we have 2 rows of pixels. That's what a height is. It's just really how many rows there are. So you have width times height. So that defines this whole pixel. That's how many pixels this whole image takes. So, but this texture has a lot more pixels than that. So, because it's a texture array. So if I want to access these other ones, I have to be able to determine that. So that's why I said when we set up the texture arrays, we need to know its width and height, because we need to know its exact locations. Now, mind you, all this math is done on the back of WebGL. You actually don't have to do any of this math. All you have to say is, I want number 1, and you get number 1, and you're done. I'm just kind of telling you how it kind of might work in the background. So that's the math. So it's width times height, and then you say index. So if index is 0, so if this is 2 times 2, which equals 4. 4, right? You don't need the parentheses. It's all multiplication. But so if that's 4, so 4 times index. Yeah, let's do it that way. 4 times index So if we say the index is 0, it'll become 0. So that means the starting position is here. If we say the index is 1, so 4 times 1 is 4, and you can visually see that this is the 4th element. Now you might say, well, that's not the 4th, that's the 5th element. Arrays start at 0, so that's 0, 1, 2, 3, 4. That's the starting position. That's the starting index of the first, or the index array texture, whatever. I said it all in discombobulated way. So if index for some reason is 2, that's 8, and there's our 8th index. So that's what's happening in the background. So we need to define its width, its height. So this way we know how big in binary, or how many pixels there are, because it's based on pixels. So we know how many pixels there are. So this way it's very easy to know each one as an index. So this way you get it that way. So that's what a texture array is. But like I said, this is all built into WebGL. You don't have to worry about it. And I made this all huge. Let me scroll to the very, very top. So we're gonna, that looks good. Yeah, why not? All right. So I'm going to load in an image without the downloader because I want to keep everything on one page to try to keep all the code together. And we have a function called load texture array, which it also exists in the GL func class, but I built it here because I just want, like I said, I want to keep everything together. We're going to load in a custom array. And we're going to have a function that builds a grid of quads. So instead of creating a grid and connecting them with triangle strips, it actually creates individual quads in a grid fashion. So this way we can define each quad its own texture to render. And we do that by, like I do a lot of it half the time for prototyping, I use the W component of the vec4. So I just pick a random number between 0 and 5. And I save that as a W component of the 4 points that make up the quad. And that's it. And that's all that it is that I'm doing right there. And then to load a texture is the exact same, almost the exact same code of loading a regular texture. Everything's the same. The only difference is this. Instead of loading in a texture 2D, we load in a texture 2D array. Everything was almost identical just by changing that little piece. The only thing that changes is which function you use to upload the image to the GPU. This was the original one, which is text image 2D. And you just pass in what kind of data it uses and what's the binary of it. And then image, and then the actual image, which is the array, or the image I actually loaded. So I'm actually sending the image over. This is the 3D one. So it's text image 3D, but it's for textures array. Same thing, you define the data the same way. Like I said, the only difference is you define it by width and height, and you use the pixel width and pixel height, and the image count. So if I know there, like I said, if I know there's 6 textures, I say I'm putting 6 textures in there. And then you bind your texture and everything else. It's all the same. So that's how you create a 3D texture. It's the same thing as 2D. It's just 2 different changes to it. Is the texture type that we're loading in, and we use a different function for uploading the image with additional 3 parameters of data. And when we load a texture into a shader, like I have the shader function here, I have it's set uniform. The code is very simple. So that when we load our textures, we have to activate a texture slot. I forget how many there are. I think it's like 16 or 32. How many textures you currently have active. You bind your texture, which is the texture ID that you get from here. When you create texture, you get a value, so that's the value passed in to bind the texture. You're binding that value to that texture slot. And then when you uniform, you bind the uniform location to that texture slot. So you don't tell the uniform, like in case it's been a long time since you actually built textures from scratch, you don't tell the uniform the actual texture ID. You tell it the location of a texture slot. So, and 3D is done the exact same way. The only difference is instead of binding a texture 2D, you bind a texture 2D array. The end. So when you set up the uniforms, that's the only difference you have to do, just to add that little extra thing. You can probably keep it all together as one function. Say, is it an array, and you just bind it with a different type. And that's it for textures array. That's all you have to do to it. And if I go back to here, that's it. Here's my quad, and each quad has a random thing. And if I refresh, you get new textures assigned to each quad. And I have culling still on, so I don't render the back faces. And there's the texture I'm loading in. Because I'm not using the downloader, so I'm just dumping it on the page and then using the reference to the image to save it to the GPU. Now I'm done. You can leave if all you care about is texture arrays. Now we're going to have fun. I used texture arrays to create something that I've been promising to do for a long time, and I finally have enough code built up to do it. And what I wanted to do when I created the voxel system was I wanted to create this. I wanted to create the portal map editor because I think I love how it works, how it functions. It's really cool. And in general, the portal level editor could be a game itself. Like once you create the game, you can just walk around in it. Portals actually creates a really good 3D world. It doesn't look anything like this 2D. No, that's not 2D. Like this simplified version. Like it looks like the actual real world in Portals. But it'd be kind of cool. Just create this and just walk around this itself. So I rebuilt the voxel system for EACS. There's nothing really that much change to it. It's just small changes here and there to use components and systems instead of using objects. Object-oriented language. And if you go to the lesson files in GitHub, the texture array is the file I was for this lesson, but we have the map. And with this map, as you can see, here is a voxel cube, and it's using texture arrays. And these walls are actually the texture quads for the lesson. So these are just a grid quad or quad grid, and these walls have the random, and the bottom and top have just one. So they're just one color or one texture from the array. So I can render all of this in just one mesh. So what else we got here? In the case of this thing, I actually built it as 6 different faces, and I just aligned everything together. But ideally, I could just build this as one actual mesh, and it'll run just once in the shader, which probably be more efficient. But I didn't do it in the terms of efficiency. I just did it just a prototype. And you can see, like I said, the back faces are being called, so I can actually rotate and kind of see the inside of the cube. And once I'm inside the cube, it looks really cool once you actually are in there. Whoa. I can kind of rotate and I can see the back wall. So here you go. And like I said, I rebuilt the voxel system. And if you remember where we left off with voxels, I was able to create voxels on the fly. And I can create this. So here you go. I'm using the right click and just poke anywhere where I want. And I can start creating things. Start creating things. I can just start making platforms. So I can zoom out. I need a better camera controller. But yeah, here you go. So there you go. It's starting. This is more like Minecrafty, but like I said, by using these textures, it looks like the editor. because the editor kind of functions that way. The only difference that the editor does is you can select the quads, and then you can just drag them, and they pull in and out, which I want to do in the future. But for now, this is as far as I got with voxels. At some point, I'm going to maybe do like a voxel selection, so you can pick, or maybe a face selection actually. You pick the faces, and then you can extrude, which essentially just does that. It's just the same thing. It just looks prettier, and it's easier to pick like 5 pieces and then zoom them in and out. So this way I can just keep pulling, and it just keeps making the platform bigger and bigger, or I can keep making the platform smaller and smaller. And of course, down the line, I want to get back into WebVR, so this way we can kind of sit in this space, walk around, and just create cubes, right? And create these spots. So it ends up being like 3D Minecraft or VR Minecraft. And then, of course, one of the big things we need is collision detection. So this way we can actually walk on these, maybe jump on them, so we can use them to kind of, like I said, use these as steps that we can kind of just traverse this space. And of course, at the very end, once all that is built in, you got to be able to build chunks. So this way I can go beyond just one chunk, because you can go in all different directions. You got this guy who, I don't know, he did something really crazy. He made a maze. Can you imagine if you built this as VR and you were able to kind of walk around and slowly build the maze inside? It's insane. So yeah, and like I said, the texture arrays. So there's so many different types of textures that the editor uses. And that's just a voxel maze, but that's not a voxel maze, just the plain old maze. But yeah, like I said, so yeah, this is really cool. I love it. This is I think this is great. Like all the source code is going to be available for this lesson on GitHub, so you can go right at it. I'm not going to explain how I rebuilt voxels because it's the same code. It's just I use it with the ECS design pattern. So I just built everything with system and components in mind, but most of the code is practically the same. And like I said, and it's kind of cool because the walls disappear. Because like I said, I'm doing calling, so I get to see this. So I can actually probably do this. There you go. See, it's neat. I love it. It's in. The only difference is you can't do this in the portal editor just to make these invisible spots. But maybe I can. Maybe I could just make these just spot that just exists there. So there you go. It'd be totally awesome once we can kind of just walk around it. Like, I don't know when I get to that point because there's so many other things I want to do. But yeah, I'm getting there. Like I promised this like months ago. This is where I want to go when I started creating voxels. And I'm at one good prototype starting phase of building that thing. What I need is maybe like lighting, because the lighting is really great. Like, I don't know how this lighting works. It's kind of this weird square shape. So I'm not exactly sure. If you know how this lighting works, I'm like a beginner when it comes to lighting, so I don't know how lighting works. I know how lighting works. I just don't know how to apply lighting and different types of lighting to kind of get some of these nice looking effects. I don't know if this maybe is a spotlight. So, but yeah, if you look at it in different things, the spotlight acts differently. So yeah. So if you know how this lighting works, that'd be great, because I would like to add it to this, and it will actually make it look more like this. But yeah, like I said, it's a pretty good starting prototype. Considering, it's got the textures, it's got textures arrays. For the textures, these are really low quality, the 128 by 128. But I did recreate them as 512 by 512. So I'm going to post them on Patreon for my patrons, because you guys give me. I want to give you guys something for giving me something. So it's kind of like a little reward for them. So here you go, the little reward. Just the higher quality versions of the textures, and as I go on, I'll probably end up adding more textures, and those will be just added to the Photoshop file. So yeah, I love this. This is freaking great. But the source code is free. You don't have to pay me for Patreon or anything, whatever. All the source code, all this is free on GitHub. Go at it, have fun with it, build something, add collision to it. I think someone did show me a long time ago. They took the beginnings of my voxel system and added a little bit of collision here, so this way they can kind of jump and walk on it. So if you're still watching, here's a more robust version of the voxel system if you want to re-implement. And there's some textures, so you can do some funky things like this. And use texture arrays, so you don't have to use texture atlases. So yeah. Yeah, this is cool. I love this. You can leave now. I'm just having fun. You know, this is a voxel system, so this voxel system works fairly well. What I need to do at some point is do greedy voxel algorithm. So this is instead of creating quads for every face, like let's say this big chunk right here, I'll just make this as one giant face, just one face. So it'll be just 4 vertices with a line through the center. And the only difference is you just have to calculate the UVs, where instead of saying between 0 and 1, it'll probably be like 0. Let's say between these two. I'll just get rid of that. So instead of sending this being, let's say this corner being 0 and that being that corner being 1, I have to say that corner is 2. So this way the textures still work. The only difference is it'll make this very difficult, like the random textures very difficult. So maybe I can't do greedy for this specific thing, but I should do greedy for other things just in case I want to make more efficient voxel worlds, like especially a voxel world, like with just terrain. Like voxel terrain is always the same texture. They don't have to worry about it. But if I need these very specific random textures, especially since I have the face, all these faces have the exact same texture. They're not random because it'll be tricky. Only the quad walls have the randomness. So it's not perfect, but I love the fact that I can kind of just see through the walls and kind of see it and just add to it through the walls, because I'm not colliding through the quad, because the quads don't count. All right, that's about it. Yeah, that's it. That's about it, really. Yeah, it goes right through. So, yeah, that's it. So that's texture arrays, and that's the beginnings of the Portal editor. Hope you guys have fun. Hope you got to do some really cool things today. So again, please like and subscribe, and again, thank you, Patrons. I will be giving you the high quality version of these textures on Patreon soon. I just need to package things up a little bit. So see you guys in the next video.